Hey everybody, welcome back to Adventures in Machine Learning. I'm here with my co-hosts, Michael.
Hey, how's it going, everyone?
And I'm Ben Wilson. And a couple of episodes ago, Michael and I were talking through this really cool blog post about rethinking ML monitoring. And specifically, we were going through this list of 11 topics. We talked about data distribution changes, ownership and production, training serving skew. You can check out that older episode in the list. But we wanted to revisit today and finish this list and talk about some stories that we've seen, things that we've may have messed up, or things that we've had to build around protecting against some of these things. And where we left off was in a production challenge that is concerted adversaries. And this is the concept of sort of algorithmic security, where when you have a model deployed in front of humans, or in front of algorithms that humans develop, and you might have some actors out there who want to abuse your system. And this topic concerns, how do I protect that? How do I even detect it as well? And are there things that people are doing either on the platform that the model is interacting with, or if you have an API that's exposed for people to use, how do you make sure that model that's deployed is not at risk of being influenced or generating predictions or inferences in a way that doesn't do what you intended it to do?
Hey folks, this is Charles Max Wood from Top End Devs, and lately I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast, and you can actually hear a little bit more about my story about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv, and I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com.
So what are your thoughts on that, Michael?
Yeah, I have a couple. The first is that I think considered adversaries is very industry specific. I haven't personally experienced a ton of mean people trying to break my code, at least outside of the company. And so I think it's very specific to industries that deal with a lot of money or that are just very large companies. So I'm sure banks have a lot of trouble with this. I remember listening to a podcast a while back with one of it's like the Just Lulz group or something, where they just hack stuff for fun and show how vulnerable the entire system is. And then they would mainly target big companies or immoral companies. So I haven't worked for money-based companies or immoral companies so far. So I was going to actually kick it back to you, Ben, and see if you could share some of your vast wisdom on the subject.
I mean, I worked at an e-commerce company years ago, and we didn't have a lot of ML that was deployed to end users other than recommendations and things that would aid in browsing and traffic, stuff like that. We did have back-end models that were attempting to determine whether transactions historically were fraudulent. But a lot of the stuff that was actually processing payments and making sure that people weren't stealing a credit card and using it to buy a bunch of stuff and ship it to addresses in their neighborhood where they'd go and steal, packages off of somebody's porch. That stuff was handled in more old school means. And the rates were actually relatively high of fraudulent activity. But there's a lot of companies out there that have active models that are processing transaction data. And, you place this order, and there's a bunch of features that we have about that user account. A lot of that data is acquired from third parties, so you can build this sort of threat assessment based on the data that you have at time of transaction, right before it goes into the point of sale system, to say, should we actually process this? order? Should we accept payment? Do things match up? And the hierarchical implementation of things like that, where it's basically a manually coded decision tree, is historically how you would do stuff like that. Say, hey, does the address on file does it match the credit card address that you do an API call to the credit card company and say, hey, what is the registered address? It's usually why you have to fill that stuff in, by the way, when you make an online transaction. If these things don't match, then they're going to say, hey, we can't process this payment. Criminals are much smarter than that, and they get pretty clever. So in order to combat some of the stuff that they figured out about how to get around the old school security, companies are putting models in production to do that prediction, to say, okay, we know this amount of data about this customer, about this transaction. Is this fraudulent or not? Sometimes it's after the payment has processed before goods have shipped. And you do that analysis of everything over the last 24 hours, rate the probability of fraud. Now, concerted adversary would be a group just like what you just talked about, the lulz group, except they might not be doing it just for fun and just to read a blog post and expose people on Twitter saying, hey, your model sucks, and hey, this is how we broke it. The real criminals are trying to stay under the radar as much as possible. But in order to figure out how to stay under the radar, they either do brute force tactics of just try a bunch of different things and see what actually makes its way past the fraud detector, or they want to make sure that if they find a loophole that hasn't been patched with a model retraining, that they don't expose that in a way that makes it noticeable for a human looking at the data. You might find out about it months later of like, hey, this was a chargeback. This person ordered $5,000 worth of goods over a 2-week period, and then we didn't receive payment from their bank because there wasn't money in the account when the transaction went through or something. So to detect stuff like this, it's very important to have active retraining, or at least passive retraining, where you're taking your known good values of, if you predict something is non-fraudulent, but it has a high probability of being fraudulent, and then you find out 2 weeks later that, hey, fraud actually occurred, you need to make sure that you're retraining on that data to say, hey, this is a fraudulent label, the nature of that transaction. But it also might mean you need to adjust your thresholds for probabilities to classify that, or you need to build a more complex model or a multi-stage model.
Right. So in these cases, the value prop of many of these organizations is fundamentally based on prediction algorithms. So one way to get around that is try a bunch of things and see what slides under the radar of the algorithm. What other methods could people use to bias the algorithm or just influence the company to their benefit?
I mean, depending on what what that exposed API is and what that model's implementation. Like, we're talking about fraud, but there's so many different online learning systems that people can use. Sometimes people are trying to make a name for themselves in a news story. They want to get published. So they go and see, hey, what happens if we take a socially sensitive topic and this massive tech company gives this API to classify humans. And, what if I pass it data that I know is going to make people understandably very upset, and see the response that comes back, and then write a news story about it. And that is an adversary to your model, as an adversary to your company. And when we talk about bias and influencing how a company is perceived in the eyes of the public, that can be helpful in the long run, to make sure that you're building models that aren't subject to, sensitive bias. But in the short term, it can be really painful for a company. So it's important to know an adversary might be sending a bunch of data to you for classification or prediction, that the pattern of their requests just doesn't make any sense. If you look at the usage patterns or hitting from a single IP address, does everybody, is there an incredible similarity in the features that are coming, just slight modifications in them over a window of time? Are they sending 100x the request volume that any other user does at this time? And those sorts of controls, you can work with your front end team and software engineering at your company to say, hey, here's some things we need to maybe look out for, because this could be a sensitive implementation that we're releasing to the world, can we make sure we're checking this? Just do, windowed evaluations on the logs and say, what is my rolling counts of requests from IP addresses over an hour period or a half an hour period? And if something gets above that threshold, do we lock out that account and say, hey, you can't hit our APIs?
Yeah, and so you're mainly talking about supervised like modeling, where theoretically a fraud team would label whether something is fraudulent, and then you can train on that.
Mm-hmm.
But it also seems like it'd be, if you have enough faith in your unsupervised methods, it seems like it would be a great application because you're essentially looking to find outliers or differences in data. So if you have the right distance metrics, you can just look for high distance between users or whatever the entity is, and go from there. So just the thought.
Yeah, some of those, like most of those, are going to be post hoc analysis where you'd set thresholds based on like a batch evaluation that you're doing. It's just because it's so insanely computationally complex to do those calculations. You're calculating stuff like Earth movers distance between distributions, the permutation calculations of saying every user, or even if you're doing groups of users, like, hey, I'm going to use unsupervised learning to cluster user behavior together, and just using like k-means or something like that. And you say, all right, we have 150 different usage groups, and I want to see the Earth movers distance between these groups over time. The number of computations that you have to do is staggering. So typically you do that, after, like, maybe once a week or once a month or something, and establish your baseline for each of these groups. And then on the fly, when you're calculating stuff over a windowed time period, you say, how far is this user outside of the distribution of any of the groups, or the group that we've assigned them to? Are they doing something really crazy right now?
Yeah, a really interesting topic. But in the interest of time, we're going to move on to the next one, which is point 7 in the list. And it refers to model readiness. So the question statement is, how will I compare results from a newer version of my model against the in-production versions? So this mainly refers to knowing when a draft of a model is ready for production, and how it will compare to the current version, and what potential issues can be introduced, what potential improvements can be introduced. So my initial reaction was that we would use a ton of versioning. But Ben, I was wondering if you had additional thoughts on doing more than just writing a crap ton of tests.
I mean, testing in general is going to be a very broad topic. So are we doing proper unit tests before we even consider merging that as a release candidate branch to merge to master, basically, to create that new version of our code base? We should be doing that. Are we doing integration tests, which is, are we running this on QA data and saying, do our predictions even make sense? Like, are they solving the problem still? We just retrained. We need to validate that things look normal. But then model versioning for checking against production data, there's a bunch of different ways to do that. Stuff that I've seen is taking, say, the last day of prod data, dumping it to a QA or a validation environment, running that new model and the current production model against that data and seeing the differences between the predictions. And if it passes a test, then you say, hey, we're pretty good to go. Also doing stuff like blue-green deployments, where both of them are deployed at the same time in different environments. And this, of course, we're talking real-time serving here. But we would be routing traffic. Say, you could do like a canary deployment. So A is in production, B is now deployed. We're going to route 5% of traffic to B and make sure that everything's working properly. And then we route more and more traffic to that over time. And then we shut off A. B becomes the new A. And you can do shadow deployments too. And that's usually for super sensitive use cases like financial industry. They're definitely doing stuff like that, where both models are running in production for could be a couple of days, or depending on the retraining frequency, maybe just a couple of hours. But you're looking in real time at the predictions of both models, and then you have some human in the loop that's saying, okay, model B is good to go. Let's route all traffic to B.
Yeah, that makes a ton of sense. And blue-green deployment sounds a lot like A/B testing. Essentially, with blue-green deployment, it sounds like you mostly focus on whether things are breaking, whether things are making sense. Mm-hmm. But often when you're productionizing models, you're looking to improve on the current state. So what you can also do in that blue-green scenario is if you just have sufficient sample size, you can look at some core metrics and see if it's actually doing what you want it to do. And again, I'm a fan of A/B tests because they're the gold standard of causality. So just a fun note there.
Yeah, definitely. And it's really the only way to know the most important question in all of ML work, all of data science work, is how much value is my group, my team bringing to the company. That's what gets you more headcount. That's what makes the company money. That's what gets accolades and promotions. And that's what people, that's what we're paid to do is to solve problems. And if you're not testing that and really determining how much of an impact, how much of a lift, or how much of an efficiency improvement are we doing, if you're not doing that testing, you're not going to know.
Yeah, it's also a super, super hard question to answer. I remember we were working at Tubi, we were working on some similar projects where you're trying to evaluate every team and figure out how much they contribute to overall lift in our KPIs relative to organic growth. And oh my God, like the politics, B, isolating factors. Like even we were just trying to isolate experimentation, and there's so many biases when you graduate experiments that actually have negative lift or don't help KPIs. So the graduation criteria changes depending upon the experiment. Just isolating the impact of experiments over a quarter for a given team, it's really challenging.
Yep.
And then a second point is that we're not just looking to improve or increase lift, but we're also looking to keep the bills or the lights on and pay the bills. And so it's really hard to quantify the value of just maintaining status quo. So it's a really, really tough problem.
Yeah. And most companies are budget constrained, resource constrained. You're not going to work for a company. There's no company on the planet that's like, hey, we have infinite budget, infinite time, infinite humans. Like, let's build the most robust system that we can do. Nobody's doing that. People are like, hey, how much time do we have? How many engineers do we have to dedicate to this, to building an A/B testing for this particular use case? That's what we got to do. And we build what we can build. The ideal state, yeah, it's very complex and really cool, but I've never really seen one that's been built that does everything that people want them to do.
Yeah, that makes sense.
Yeah, and kind of related to that, item number 7, the pipeline health issues is the next one on the list, which is like, why does my training pipeline fail when executed? It's a frequent question that I've gotten over the last several years. Or why does a retraining job take so long to run? How often do you get this in your work?
Well, I don't write code with bugs, so I've never experienced this, but other people experience it. No, it's a really common problem. There's just so many moving parts. And the thing that I personally struggle with the most is handling / ensuring quality of the inputs. So you can write a SQL query that pulls data from a database, but as soon as something in that data changes that you didn't anticipate, everything goes to shit. And it's really frustrating because you put in all this work to have a super clean pipeline in like the midpoints, but you often as a developer have to go into other people's realms, understand the outputs from their realm, and see how it will connect into your pipeline. So it's not just doing your job, it's doing people like the prior upflow pipeline job, but it's also doing the downstream pipeline job of how it will be served and how it will be consumed. So there's so many moving parts, and I run into problems occasionally. How about yourself?
I don't think I've ever shipped a solution that uses machine learning that's never had this problem ever in my career. There's always something that goes wrong. And even if you get everything right on your, you move from MVP, you get into a production deployment, all your tests are all set. You have monitoring set up on features that are coming in. Exactly as you said, man. Like, what's it going to look like 6 months from now? Somebody in the data engineering team is going to make a change. Their code base is not sacrosanct and immutable. They're doing process improvements all the time. They're refactoring code. They'll create a bug eventually that might cast a value into the wrong type, or something happens in data acquisition land from ingesting data from a REST API that your company is maintaining, that eventually makes its way into the data warehouse or the data lake. And what happens when somebody renames a field? They start pushing data to a new column effectively in a table that you weren't even aware. Your model, thought it was called ABC. Well, they changed it to CBA. It's the same data, just a different column name. Your production pipeline is going to blow up. Now you just have a bunch of nulls. If that was an incredibly important feature in the vector that's going into retraining, now your model sucks because it's inferring that as null and filling in a value there that's all uniform. So it's going to happen. And you nailed it when you were saying about data coming in, breaking things, and having to set up monitoring. It's incredibly critical to being aware of what the problem is, because actions like that prepare you in a way that it's going to minimize the downtime that you have. So if you approach every single data science project as things will go wrong and preparing for that, you'll start writing little bits of code that'll help you diagnose, troubleshoot, and debug in order to get that back up and running as soon as possible. But if code sucks and it's just a big messy script and you can't really read it, you're never going to troubleshoot that. That system could be down for weeks while people are reverse engineering how this thing was wrought into being. So it gets really, really tricky.
One question for you. Sorry, go ahead.
No, I was just saying the last part of that, the retraining job taking so long, that's definitely something that in what I was doing at Databricks up until last year, that was kind of what I was doing a lot of times with a lot of companies. They're like, hey, Spark's really slow. When we trained this the first time 6 months ago, it trained in 40 minutes and now the job's taking 4 hours to run. And there's an infinite number of reasons why that can happen, whether it's just organic data growth and not filtering your training data, or it could be something a little bit more complex, like you're using Optune or HyperOpt, and it's selecting parameter estimations that are influencing hyperparameter selection that just make the model take longer. And every model that you're using has some knob that will make it run really fast or really, really slow.
That's a great point. Going back to the prior point, I was wondering if, just out of personal interest, if you had any thoughts on how you approach building end-to-end pipelines. So one example would be you trust the crap out of people on either side of the pipeline. So the data engineer that brings you the data, and then the front-end person that builds the front end for your model, let's say, and just assume that their inputs will exactly be those inputs that they say. On the other extreme, you could try to do their job for them almost and go in, read all their code, figure out exactly what's going on. But that theoretically would double or triple the amount of work that you have to do. So I was wondering how you strike a balance between ensuring quality on your own side versus trusting the people on either side of the pipeline.
Oh, I'm going to be really annoying here and say neither. The trusting, that implies that I'm not talking to them, and that it's just a throw it over the wall. Hey, yeah, you create this table or this data set that I'm consuming. That I'm like, if you say, hey, I'm going to trust that person, that means you didn't even talk to them. You didn't ask, like, hey, what is the nature of this data? How often do you guys make changes to it? And where do you get it from? And how many times has this pipeline broken in the last 6 months? Can I just look at your Jira board and see what your support tickets are? And those are really important questions to ask. And then on the front end side, I'm not a front end expert. I know some architecture about serving, but I will never know as much as like a true front end developer would know about how to set all that stuff up and what that particular infrastructure looks like for that team. So I'm not going to review their code because it's not really a useful way to spend my time. And usually the code bases that are supplying like a website, they're pretty complex. And reading through tons and tons of lines of JavaScript or TypeScript is just not my idea of a fun time. Same thing with data engineering. I know way more about data engineering than I do about front-end engineering, but depending on how they have everything set up, it could be a lot of time spent trying to reverse engineer what they build. I've always found that the easiest way to handle both is to get both of those groups in a room with me or with me and my team we just say, hey, we all own this project together. Let's work together. I want to hear ideas from everybody. Let's work as a team to solve this problem. And people get super excited about that. They're like, hey, the ML engineering team wants to, build this thing together. It's like, yeah, it's a cross-functional effort. And the more that you make friends with people on either side of the work that you're doing, the more successful it's going to be.
Yeah, what a concept. Teamwork is helpful. And then to the second point, I was wondering if you, in your experience, what is the most common newbie mistake that leads to model training taking a long time? So is it having too much data? Is it having the wrong model choice? What is it?
I'd say the most common for both supervised and unsupervised learning of vectorized data is definitely having too much data. And that's not too many rows of data, although that can be a problem as well. I can promise everybody listening, you don't need 10 terabytes of training data for a model. It's kind of ridiculous. But what I see is too many features and not doing exploratory data analysis beforehand. I see it with a lot of people who are recently acquired the job title of data scientist at a company. Maybe they're the first person that has been hired at that company, so they don't have anybody more experienced to ask. And they certainly don't teach a lot of this stuff in school in a program that I'm aware of. And not a lot of people write about it either. So these are just things that you learn on the job from somebody who's screwed it up enough times in their career to know better, then they can pass that knowledge on to somebody more junior. But usually I see that with a relatively new to the field person who's like, well, the model's going to perform better if I give it more information. And logically, that makes sense in our minds. Like, hey, if I have, these 1,000 features about my customer or about this thing that I'm trying to predict, I should just train the model on all of them. It'll do better, right? And no, it doesn't. Curse of dimensionality comes into play where if you have too much of a signal in there, the model's going to struggle to actually converge properly and optimize itself. And then blindly putting things into a vector during training, you have no idea what you're putting into that thing when you do that. So I see a lot of people do that. They're like, hey, I'm going to take all the features in this table and put it into XGBoost. And then I'm going to call feature importances. And whatever the top 5 are, that's what my production model is. And I wouldn't even be able to tell you how many times I've seen somebody do that and then had to point out to them like, hey, these 5 features that you have selected, they're actually directly correlated to your label. And that's why your holdout validation is so bad. So please stop doing that. You're leaking the label in this. Or in a regression problem, the Y term is indirectly correlated to some of the feature terms or a combination of interactions of feature terms. So if you're not doing the analysis up front, it's not worthwhile to approach ML like that. And a lot of times it just takes the thing that much longer to run too. So,
hi, this is Charles Max Wood from Top End Devs. And lately I've been coaching some people on starting some podcasts and in some cases just taking their career to the next level. Whether you're beginner going to intermediate going to advanced, whether you're trying to get noticed in the community or go freelance, I've been helping these folks figure out how to get in front of people, how to build relationships, and how to build their careers and max out and just go to the next level. So if you're interested in talking to me and having me help you go to the next level, go to topenddevs.com/coaching. I will give you a 1-hour free session where we can figure out what you're trying to do, where you're trying to go, and figure out what the next steps are. And then from there, we can figure out how to get you to the place you want to go. So once again, that's topenddevs.com/coaching.
Yeah, it's really interesting you say that. I was literally 2 days ago reading a paper about L1 and L2 regularization and how it is related to sample complexity. So I might butcher this, but I think I can not completely butcher it. As you increase the number of features with L1 and L2 regularization, the sample complexity, in other words, the number of samples that you need, increases to get a signal. And in the paper, they were proving that with L1 regularization and logistic regression, there's a logarithmic relationship between the number of features and sample complexity.
Yep.
They were trying to essentially extend this logic to more complex models like deep neural nets or something like that. And it gets a lot more complex, but just something to really consider is that as you increase the number of features, you also increase the number of samples that are required to fit the data well. And so dimensions both on the X and Y axis can increase dramatically, which can make your training time really long.
Oh, yeah. And just expensive machines you'd have to run as well, because that optimization is recursive. It's just trying, it's either using bootstrapping or jackknife sampling in order to go through and say, I'm optimizing, making this test of weights that I'm going to use, or this test of decision logic that I'm going to use for a particular split. And it just has to keep on doing that. That's where you see that like max iter. Like that's the max number of recursive iterations that you're allowing that thing to do, whether it converges or not. And yeah, it can get really expensive.
Yeah, for sure. Cool. So moving on to the next point, we're going to talk about underperforming systems. And this is basically talking about high latency predictions and why latency might be different in a production environment versus a training or testing environment. So Ben, what you got to say about that?
This is a big topic, and not necessarily a data science thing, but definitely an ML engineering thing. It depends on what you're serving and your latency that you have. There's things that you can't control from a data science perspective, from a model inference perspective or prediction. And then there's stuff that's just completely outside of your control. The team may or may not be in control of those services. But if we're going to break it down to the thing that is directly in control is model complexity. And when you pass a feature into an online running artifact that you have say like a Flask server wrapped around, that's processing REST requests. What is that model? How many features are in there? What is the complexity of that model? If we're talking about a linear model, there's a really fast. It's just an equation. So it gets the answer in pretty much 0.1 time. But if you're talking about a really complex tree-based algorithm, and the tree can be very simple, and the processing down through decision logic can be very fast. I've also seen models where the number of trees that are part of that model artifact are in the tens of thousands. And the CPU has to process that and has to say, okay, for this vector that's coming in, where do these conditionals map out to, and what is the path that I need to go down in order to return that box's prediction. Outside of that, that's usually not what people are concerned about with model latency, although some people are with like deep learning, like, oh, I'm doing image analysis. I want to get a prediction from this picture. It's like, yeah, those take a little bit of time. The deeper that the model is, the wider that the model is, the size of the image that you're passing in, all of those have a pretty big impact on how fast you can return a prediction. But usually it's the infrastructure outside of it that dictates what the performance of that API is. A lot of people these days are using like KF serving or Seldon to manage Kubernetes deployment of pods holding their models. And then you wrap a load balancer, which, KF serving has a load balancer in it, and it handles sharding for you. So it's a great management tool on top of Kubernetes. So you get something that is a little bit more plug and play and can scale to pretty high request volumes. But if you are rolling your own and building all that from scratch, you're like, hey, the data science team, we need to do a REST API that serves a model. Well, we're going to do it on Kubernetes. And it's like, yeah, that's great. Like, do you have DevOps working with you to manage that Kubernetes deployment? Who's maintaining these VMs? Who's doing source code management of all of these different packages? What happens when you need to upgrade KF serving? What happens when the next version of Kubernetes releases? Who's going to set up the cluster for you? So it's all of that stuff can impact the burden on the team and can also impact the performance over time if you don't have enough resources set up to say, hey, when the next major release comes out of, name technology project here, when that gets released and you now have to upgrade to that new infrastructure, you need to set aside a lot of time to basically do a spike again. So like, hey, we're going to do a migration. We need a couple of days from this sprint to just figure out what's changed in this API. And then we need, over the next quarter, we're going to set aside 3 entire sprints just to do this upgrade. Well, Can you support that in your team? And if you do that migration, how do you verify that performance doesn't suffer from your different models that are being served? It gets really complicated.
Yeah, I mean, it sounds like it.
And then there's other stuff that can be bolted onto that. So most complex REST APIs that are customer facing usually have a business logic mapping layer in front of them, where the front end, like an app or a website, will be querying that serving layer from the ML engineering team, saying, hey, here's my endpoint. Kubernetes is handling the distribution and concurrency of this. And then you get a result back of a prediction. Most companies don't want to just raw use that prediction. Usually have some sort of logic that's in there, whether it's validation logic. If you're trying to predict some future state of a continuous variable, there are bounds that you should have on that. Like, please do not predict negative infinity or positive infinity. Or there's something that's like, hey, how much should I bid on this thing? Or should I permit a user? Or what is the probability of somebody doing this thing? Making sure that you have controls over that and fallback logic. What happens if the prediction fails? What happens if it times out? There's a lot of things that can go wrong. And that business logic execution is another latency consideration to handle because that's got to run.
Yeah. Yeah, exactly. You're talking about sort of post hoc rules or post processing rules to ensure that the outputs are valid and aligned with business goals. Another really effective way to do this is, well, two. The first is you can pre-process a lot of things. So if user is greater than 5, or I don't know, height is less than 2, you can not put it into a model and instead output specific results.
Exactly.
And another option is to actually have that be the model.
Mm-hmm.
I've seen some surprisingly effective models where you do a really effective offline analysis and then use those values as the prediction or to predict.
Can confirm. I have released production models that are a manual decision tree before. And the crazy thing is I've done A/B testing of that compared to an advanced XGBoost implementation that spent an entire week tuning and getting, this perfect MSE value, and then did an A/B test and did a blind show to the business of the results of both. And I said, which one do you think is the more advanced ML implementation? Every single person in the room selected the one that performed better as being the XGBoost model. And then I showed everybody. I was like, here's the 50 lines of if-else statements that you just selected. And then this other one is XGBoost.
Yeah, again, we're trying to generalize. We're not trying to build the biggest and baddest thing.
Yep.
We're trying to find the core features that predict. And sometimes the rules are really simple. If you have the subject matter knowledge to develop something like that, or the EDA and causal modeling tools to really understand the problem, it can be a lot better than advanced ML.
100%. It's always better if you know the problem space and you know those conditionals that you want to do. If you're a data scientist with that knowledge and you're afraid maybe that people are like, oh, people are going to think I'm a fraud for building something that's just a bunch of conditional statements, just don't tell them. Don't tell them what you built. Just say, I'm solving the business problem. That's all that anybody really cares about. It's all your CEO or CTO or anybody. That's all they care. Is your team making money for the company? And if you are, nobody has to know.
No.
So then our next one is cases of extreme events, black swan events. Well, black swans are very rare, but extreme events do happen quite often. But how can I track the effect and performance of my model in extreme and unplanned situations?
Yeah, oh my God. That's a big area. So there are tons of offline ways to do it where you can look at data drift and leverage techniques that look to see if there's a difference between data today and data tomorrow. If there's a large difference, we should go in and check it out. There can also be, we can leverage those to trigger autonomous retraining. There's a bunch of different ways to do it. I think it's very subject matter specific and very model specific and very application specific. So there's no one best method, but as you said, it's a really good idea to plan for things going wrong and plan for things changing in your data. So what are your thoughts?
Yeah, to compound on what you just said with this is a big subject, it is. And it's a hot topic right now in the MLOps space. So many companies are working on it. We had somebody, a group on the show a number of months ago, Evidently AI, Emily and Elena came on to talk about their open source tool that's doing drift monitoring. And there's other tools that are out there that people are trying to get started with. And there's ways to make those systems incredibly robust if you're doing it yourself and you're not using a pre-baked open source package. And typically where people can go a little bit awry is delving too deep into the rabbit hole of accuracy of thresholds for alerting. It's something that I've seen at a number of different companies. People are like, well, all of these process control rules are built around, parametric tests and normal distributions, but I have non-parametric data. There's no way that I can, use some sort of test that is like this. I got to implement something from scratch. I'm going to do BAC testing, and I'm going to make sure that I'm doing, proper bootstrap sampling of my bootstraps in order to determine what these confidence intervals need to be. You can go down so deep in this topic to make sure that you're catching the early signs of an extreme outlier event in order to alert or trigger retraining or trigger an attempt at retraining if it's even possible. But the thing that I tell most people is start simple with any of this stuff. There's nothing wrong with borrowing from the entire industrial engineering practice. Industrial engineering uses statistical process control rules that were popularized and implemented for the first time back when industrial manufacturing started really kicking up in the post-World War II era. So the principles of Six Sigma and lean manufacturing. Six Sigma at its foundation is the approach of process improvement through statistical monitoring of processes. So you're collecting data, you're looking at it and seeing, does this vary over time? How is it varying over time? And is it within control? And over time, you tighten those limits when you understand your data and your processes better. And I've always done that with anything that I'm doing that's very important to the business. It's super easy to calculate SPC rules. It's just a couple of very simple statistical equations. There's packages out there that do it in stats models, and you just have those limits. And you say, hey, as the data's coming in, I'm going to look at what are my distributions looking like? What is my variance over every hour over the last 2 weeks? And I'm going to just capture those data points, and then I'm going to look at what my limit should be by doing either jackknife or bootstrap sampling of my data results before to build what those variance tolerances should be. You can just use percentiles of that data and say 95th and 5th percentile. That's where I'm going to start. I'm going to check it for 2 weeks. Do I need to tighten them? You just have that in a config file. Hey, feature A should be between 110 and 135. And then you realize over a 2 week period that the model's been performing pretty well. The data's never moved between 114 and 116. Maybe I can tighten my SPC rules a little bit. And you do that over time on production monitoring to say, that's how manufacturing works. Any manufacturing process that's out there, that's how it becomes repeatable and you get high yields, is by controlling that variance. We can do the same thing with our models. You can be looking at what the predictions are that are coming out, whether it's a Pareto distribution for counts of classification or a continuous distribution. We're just checking what that variance is over time. And if it starts going nuts, we don't have to build some crazy system that's that's going to trigger active retraining, which is then going to go and evaluate what the drift is and then change hyperparameters based on the data drift. We don't have to do that. Just send an email. Send an email to the team, mlteam@company.com, and everybody gets alerted hey, massive drift happened. We need to investigate. And then you go in and look at the data and generate some charts and be looks like we're trending up continuously. That can't be good. What's going on there? And then you go and analyze it.
Yeah, would you say it's more effective to have a autonomous retraining process or just sending emails in general?
It depends on the use case and the size of the team. So I've seen autonomous, active retraining where it's detecting drifts and then kicking off retraining and basically putting that model into a shadow deployment in production and then evaluating it over time, over a period of hours, and saying, are predictions aligning better with the new model versus the old? And then if so, divert traffic to the new model. Those are really complex, and that's a business decision. And it's a business and personnel decision that the team lead should be making, and probably people high up in the engineering organization at the company, to say, does this thing that we're pushing to production, does this model make so much money for our company that if it drifts by 5% on prediction accuracy, is that costing us millions of dollars? If the answer to that is yes, then yeah, build that system and hire enough people who know what the heck they're doing to maintain and build that system. But if it's something that nobody really cares about and it's not that critical, the simplest approach is the best. Just percentile limits. It might be a script that you run every morning and it reports out charts somewhere. And if you go over a limit, you get an email that kicks off based on that monitoring script that's running. It's really all you need for a lot of use cases that people do.
Awesome. And so moving on to the final point, which is point 11. Wow, sorry about that background noise. I apparently live in a construction zone. So what we're looking to here determine is whether, look at data quality issues. So how can I ensure that the production data is being processed in the same way as the training data? Do you have any thoughts on that?
You mentioned it earlier. Pipelines is a great way. So instead of deploying a model artifact on its own, you're deploying all of your feature engineering code as part of the pipeline. And I'd say that was pretty much the standard best answer that could be provided up until about 9 months ago. Now I would say feature store. Extract out your processing data from your pipeline, create a new pipeline that generates a table, an actual materialized table that has that data. So that's a shameless plug for my own company's products, Databricks Feature Store. Check it out if you're interested, but they're great. Feature Store saves so much time. And it's not just because, hey, I can define something in dev that I trained on, and then I can take the feature store definition and promote it to prod, and it's going to execute in the exact same way. It's more that you're democratizing very complex transformations that the data science team does. What do we do as data scientists? We create features. That's mostly what we're doing, is getting creative with data to answer a problem. And whether we use a model or not is irrelevant. It's all about that data that we're manipulating and converting into a way that an algorithm or a human can use to answer a question. So when we put everything within our code base or within our notebook or within our pipeline, nobody else can see that. The only thing that's seeing that is the CPU. We're not even seeing that because we're not materializing that data anywhere. It's done as a ELT transformation. With a feature store, you're materializing that as ETL, and the data science team can see it. Your monitoring systems can see it. Your drift systems can see it. But most importantly, your analysts can see it. So other people outside of the data science group can use that data that we spent so much time working on crafting to solve this problem. Who knows what creative insights the rest of the business could draw from that data? It can be a multiplicative effort. Even though it was built for a model, some analyst could dig through that data, join it to some other information, and then have this epiphany of an insight that now changes the direction of the company. They're like, hey, we now have evidence that we should acquire this other company because they're doing this thing better than us, and this is where we're seeing the highest growth in sales or something. So let's do that and transform the way our business goes. You never know what can happen, and that's why feature stores are so important. But it allows you to do data quality measurement as well.
Yeah, that's a great point.
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
One thing that it also helps augment is if you have really large base tables that you're querying from when you're training, it really helps speed up exploration around that data, because if you have a cached version of the final features, stuff goes so much faster than if you have to query from base tables.
Oh, yeah.
And work your way up every time.
Definitely. Yeah. And how many times have you, in the process of building a model, have you had to like iterate on something, change out the actual algorithm that you're using? You're like, well, I was going to do, logistic regression, but now I got to try decision tree classifier. And now I have to change all my code and put this into the pipeline and make sure that I don't want to use one hot coding anymore. I need to do this other thing. So you're doing all these changes to your pipeline in order to accommodate, the model type that you have, when really it should just be, hey, I've already calculated my features. They're just sitting there in a table and I can query them in less than a second.
Yeah, exactly. Yeah, it's a super useful thing. And I don't really, even for EDA, I don't really not cache tables anymore. I used to query from base tables, but if you can cache a table, it's for me at least, one of the most frustrating and challenging parts of data science jobs is waiting for stuff to run.
Uh-huh.
I'm not the most patient person. So if you have even a sample of data that you can build your entire pipeline off of and then press play and it'll run overnight on the full data set, I think it's a much more efficient way to build than always working with production-esque data from the start.
Exactly. Couldn't agree more. All right, man, we got through all 11 of these in 2 episodes. So an hour and a half to talk about this table, which encapsulates a lot of what I would call production ML or production ML ops things to think about. And what's exciting to me in this industry is that so many people are trying to tackle these disjointed challenges that we've all faced over the years. When people talk about ML ops and production ML, you could talk to 100 different data scientists at 100 different companies and ask what's most important to them. And you'd get, 1,000 different answers from them. But within those 1,000 answers would be these 11 core principles. Everybody's worried about these things. And if they're not, they will be eventually. And it's just exciting to see so many companies working on making this simpler and making this into, instead of being a bunch of challenges that you have to create a bunch of custom solutions for, it's now more, hey, there's services that we can use that make this more like what software developers have now. Because 40 years ago, nobody had that figured out for software engineering either. It was just this disjointed mess of no standards. And now it's very different ecosystem writing code. And ML is going to get there. And it's an exciting time to be part of this profession.
Yeah, couldn't agree more. And just to reiterate on the comparison with software development, traditionally software development we sort of talked about this a couple episodes ago, but software development usually has a Boolean success criteria of whether we achieve the goal or we don't. But one of the things that makes ML so difficult is we're always looking to improve. And so there's just a ton of potential moving parts. And also the dependencies aren't always as robust as with software libraries. So you're using tons of different things that are built by some dude in a basement or girl in a basement. And that leads to a lot of versioning issues. And as you slowly upgrade and as your code base grows, that can be really challenging. So if you don't have millions of dollars to throw at the problem, outsourcing to tools is really effective.
So you can pay somebody else at a company who just interfaces with the basement neckbeard coder library that is very esoteric. Yeah. I mean, that's what a lot of companies like Databricks do is simplify that for end users, because it is rather complex making it all work together.
Yeah, could not agree more.
All right, man, this was fun. It was good getting through the list. And before we were talking, before we hit record on this week's episode, we were talking about some other stuff that we're going to be planning for future episodes with Michael and I talking through some exciting things. So if you want to know what those are and hear us talk about them, you're going to have to tune in till some of our future episodes. Next week, I think we have a guest on, which will be really exciting to talk through with an author. Any closing thoughts, Michael?
No, just the suspense of what we're going to talk about is killing me. I wish I could know, but I guess you'll have to wait a couple weeks.
Mm-hmm.
Cool. Well, thanks everyone for tuning in. Hopefully we'll see you next week. This has been Michael
and
Burke,
Ben Wilson.
And hope you guys have a wonderful Friday or whenever your day is.
Take it easy.
Bye, everyone.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.